Welcome to this deep dive into machine learning breakthroughs, synthesizing 152 papers from November 30th, 2025. This presentation explores a snapshot of 152 papers revolutionizing artificial intelligence, from ultra-fast hardware to ethical models. Dominant themes, key findings, and seminal works are uncovered. An engaging narrative shows how these ideas reshape technology and society. Imagine artificial intelligence predicting health risks or simulating planetary sustainability. That's the excitement ahead. Machine learning creates algorithms that learn from data to predict, decide, or generate without explicit coding. It draws from statistics, optimization, and neuroscience for real-world applications like recommendations or medical scans. Key areas include reinforcement learning for games, generative models for art, and supervised learning for classification. Challenges involve bias, computational demands, and handling uncertainty in diverse data. These 152 papers highlight interdisciplinary advances in biology, physics, and sustainability. A key theme advances reinforcement learning for smarter agents in uncertain settings. Diffusion-based frameworks like DiffSAC improve returns on benchmarks. Agentic policy optimization evolves instructions, boosting multi-turn reasoning efficiently. This overlaps with robotics, focusing on offline and non-stationary efficiency. Reinforcement learning trains agents via rewards, like trial and error navigation. Another dominant theme enforces model transparency without performance loss. Ordered sparse autoencoders like Align SAE align features with human concepts. Fairness constraints reshape explanations in healthcare, debugging biases in large language models. This is crucial for ethical applications like recidivism prediction. Sparse autoencoders decompose data into interpretable parts, aiding bias detection. This theme applies machine learning to biology and health, handling messy data for breakthroughs. Foundation models like CLEF by Xu and colleagues enhance electrocardiogram analysis with contrastive learning. Neural nets approximate phylogenetic distances and model protein affinities for drug discovery. Accuracy improves in wearables for early heart issue detection. This extends to uncertainty quantification, like photonic machines for fast reasoning. Efficiency optimizations, such as KV Pareto, reduce memory by 68 to 78%. Frugal methods model sustainability with Q-learning for global policies. Diffusion models add and reverse noise to generate data, reframed for reinforcement learning sampling. CLEF by Xu and colleagues boosts electrocardiogram accuracy by 2.6% and cuts errors, aiding remote monitoring. Photonic machines enable picosecond uncertainty reasoning for safety. DiffPPO reframes reinforcement learning for better efficiency in control tasks. KV Pareto reduces large language model memory dramatically with minimal accuracy loss. Align SAE enhances controllability in ethical artificial intelligence applications. Contrastive learning compares data pairs for robust representations used in electrocardiograms and graphs. Diffusion models generate via noise reversal, applied to reinforcement learning and Bayesian exploration. Sparse autoencoders decompose activations for interpretability in large language models. Reinforcement learning adapts via policy gradients for dynamic decisions. Topological methods capture data structures, aiding privacy in clustering. The full title is Limitations of Membership Queries in Testable Learning by Lang and colleagues. It is selected for its impact on learning theory, revealing query limits in robust artificial intelligence. Testable learning boundaries are probed, proving no speedup from membership queries. Significance lies in pushing for sample-efficient algorithms in noisy environments like diagnostics. Novelty appears in linking to statistical query dimension for hardness proofs. The full title is Uncertainty Reasoning with Photonic Bayesian Machines by Brukerhoff, Plukelman, and colleagues. It is chosen for hardware innovation bridging theory to practice in uncertainty quantification. Photonic chaos is used for fast probabilistic convolutions in Bayesian nets. Findings match digital accuracy at picosecond speeds for classification tasks. This advances real-time artificial intelligence in safety-critical sectors like autonomous vehicles. The full title is CLEF, Clinically Guided Contrastive Learning for Electrocardiogram Foundation Models by Xu and colleagues. It is selected for novelty in health artificial intelligence, improving fairness and accuracy with scarce labels. Adaptive contrastive learning with clinical metadata is employed for electrocardiogram analysis. Baselines are outperformed by 2.6% in accuracy, reducing biases in wearables. Impact accelerates equitable remote monitoring and drug discovery directions. Hybrid photonics with neural nets enable light-speed uncertainty handling. Ethical alignments via concept-aware models promote global equity. Reinforcement learning scales to embodied agents in robotics and sustainability. Non-stationary, fairness trade-offs, and eco-friendly scaling are tackled. Interdisciplinary focus addresses self-improving artificial intelligence for unseen challenges. This synthesis was created using artificial intelligence tools including GPT-Grok using model Grok 40709, text-to-speech synthesis using OpenAI, and image generation using Google. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All references are provided. Tools enabled a cohesive narrative from 152 paper summaries. Focus is placed on clarity for broad audience engagement. Subscribe to the YouTube channel for more cutting-edge artificial intelligence research insights. The title is AI Frontiers. The description is blank. Do not miss out. Hit subscribe and turn on notifications for the latest episodes. Share thoughts on these machine learning breakthroughs. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.